Let's try to understand merge sort. Consider this array. In the case of merge sort, we will divide the array into equal halves. This will be divided till this part. It will be further divided, and the division continues till we have one element in each and every subarray. Now both of these elements are combined in the actual order. They will be combined 38 and then 45. This will be as such. Both of this will be combined in the order 7 and 15 and 9. This combination will actually lead to the entire array, and it has to be completely sorted. The process of combining two arrays by sorting them is called merging. Let's try to take an example and try to understand how merging works. Let's consider this as L1 and consider this as an L2. We need to find an array by merging both of them. Let's make a pointer to L1 and call it I. We'll make another pointer to L2 and let's call it J. We have to find a list which has the size of L1 plus L2, and we need to merge both of them. You need to understand, whenever this list was created by merging, all of this will already be sorted. So when I try to create a new list by merging both of them, even this has to be sorted. Let's name the pointer here to be k. Initially we'll compare the element of L1 and L2 with the help of these indexes L1 of I, L2 of j respectively. 5 and 15 are compared. 5 is less, so we'll increment k. 5 will be copied over here and I will be incremented. Now again L1 of I and L2 of j will be compared. If you see, 15 is less than 23, so 15 will be copied by incrementing the value of k, and the value of j will be incremented this time. 23 and 37 has to be compared. 23 is less, 23 will be copied after incrementing the value of k, and I value will be incremented. Now 97 and 37 will be written after incrementing the value of k, and it will be moved to 62. Again k will be incremented. 62 will be written as it is less than 97, and as we have copied the element over here, it will be pointing to the last element. We need to add infinity to each and every list when we are trying to merge it. Infinity is nothing but any maximum number. Let's say it can be 9999 and so on. Now both of this will be compared, and because of the presence of this infinity, we will ensure the copying of this complete list. So even k will be incremented, 97 will be written, and whenever the complete size of L1 and L2 is finished, or whenever the k has reached the last index in this array, we will complete the sorting algorithm, and this happens in merge sort. Let's try to analyze its complexity. In the case of merge sort, if you see, the task required for n numbers is dividing into task required for n by 2 numbers, and we are having two subarrays of such. So task required for n is equal to 2 times task required for n by 2, and we have to merge at each and every stage. So the work happening at each and every stage can be order of n or theta of n. If we solve this by Master's algorithm, then the complexity turns out to be theta of n log n. If we just observe, we are trying to take a big problem and we are dividing it into sub parts, and we are trying to find the solution for small parts, and we are combining it. We are dividing it and we are trying to conquer it at a smaller stage, and finally we are trying to solve the entire problem. So the paradigm which is used for merge sort is divide and conquer. It is also stable algorithm. If we just observe, it is out of place sorting algorithm, because if you remember, while we are merging at each and every stage, suppose if I am merging 45 and 38, I need to create a separate list for 45 and 38 which are followed by infinity. So these are the extra space other than the input which I have been using for the completion of the algorithm. As I am using some extra memory, this is called as out of place sorting algorithm.